Hello and welcome to today's remote session. This is Tom Bechtold. I'll be your host today as we go through API security predictions for 2022. I want to say thank you to the folks over at Salt Security for making today's session possible. We got a lot of ground to cover as usual, and I want to make sure we get through all of this and all of your questions. So let's get things going. So, APIs, we use them all the time. I mean, we're connecting stuff all the time, different software things everywhere. On 24, for example, we're connecting this thing to HubSpot for different purposes. We use that and then push it into other programs too with another API. And, sometimes they work great. Sometimes they're kind of, meh, right? So today we're going to talk about not necessarily the meh moments, but, how can you be securing this stuff a little better instead of just, sloppy code where it just doesn't work right? So we've got a lot of predictions, 7 to be exact, that we're going to get into. I want to we'll get Michael on in just a minute, but I'm going to go through our housekeeping real quick. We've got our slide deck is available. We've got a nice report in there as well that Michael will be referring to occasionally, and some URLs in there to check out some of our upcoming webcasts as well. So check that out in the resource tab. We are taking questions periodically. We're going to try to get some in the different sections of the presentation as well as at the very end. We have a certificate of attendance for you available after about 40 minutes, so you'll be able to download that from the menu bar. If you're having any audio or video issues, maybe you think the slides aren't turning or whatever, On24 is kind of a smart program. It will know that you're multitasking, so it'll usually kind of freeze things for you. Nice feature for you. But go ahead and refresh your screen. F5 will usually fix most of those problems, especially if you're having any audio issues. No dial-in, so don't worry about that. But we are recording this, so if you are getting some great value out of it, or you want to share it with a colleague or revisit, use that same link that you did to join us today, and we'll take care of you for the on-demand recording. So that being said, I want to do a quick intro for our guest presenter today. We've got Mr. Michael Isbitski. He's the technical evangelist over at Salt Security, and like I said, he's going to be talking about these predictions. So that being said, I'm going to turn things over to Michael. Michael, great to have you. If you wouldn't mind, just give the audience just a little bit about yourself and maybe a little something about why you're excited about APIs.
Yeah, absolutely. Thanks, Tom. Thanks for the intro. It's good to be here. Say a little bit about myself without getting into history lesson, right? You can certainly look me up on LinkedIn, but prior to joining Salt Security, I was a Gartner analyst covering application security, as well as other markets like API security, infrastructure security, and mobile security. I did that for about 5 years, and then prior to that, I was a practitioner for Verizon for close to 20 years. Doing a lot of systems engineering, but inevitably application security work as well. So I've seen quite a bit. I've seen a lot with mobility. I've seen a lot of API design work. I've seen good and bad. It is still a relatively young industry. There are vendor solutions like what we provide at Salt Security, but practices are still kind of growing, right? Just like application security was still kind of nascent for many organizations. They weren't even heavily investing in that yet. API security is even newer on that spectrum. So we're going to cover 7 predictions for 2022 today. I am going to try to get through all 7. I'll tell you there is also a supporting blog for this that has a lot more of my thoughts as to why I think these are kind of the big heavy hitters for the coming year. Some of them are evolutions of what we've been seeing, or trends that are just going to keep gaining momentum. So probably not entirely surprising, but hopefully these help support kind of your initiatives and security strategy for the coming year. So with that being said, let's kind of kick into it. If you've been reading any media, there's been no shortage of API security incidents or API related incidents. Not all of them get classified as data breaches, right? We're gonna talk about that a little bit later. There's different ways you can kind of exploit and abuse APIs, right? A data breach is not the only potential outcome. And it's interesting to hear some of these companies kind of respond to the events, right? It's often the language of data breach, which isn't the complete picture. We're going to dive a little bit deeper on this today, but there was no shortage of incidents in 2021. I mentioned I came from Gartner. I worked with a lot of analysts that created these strategic planning assumptions. Mark O'Neill, I believe, coined this one specifically. But this is a very famous quote from Gartner where they predicted that by 2022, API abuses were going to become the most frequent attack vector. What's interesting is they do specifically call out data breaches for enterprise web applications. But as I said, there's a lot more to worry about than just data breaches. And Gartner actually just kind of revisited this prediction, and they kind of reinforced, right, that it held quite true, which it's an accomplishment, right? It's not easy to kind of predict things 3 or 4 years out, because this did, I believe, originate in 2017, right? So that's not an easy thing to kind of predict 4 years of technology evolution, but they kind of nailed it with this one, right? So the only thing they kind of missed was that it's escalating a lot faster than they even anticipated, right? API related events are kind of the name of the game these days. All right, with that being said, let's kind of roll through these predictions. I'm going to try to save time in between each prediction in case there's any questions that come in. And then I'll also save time at the end in case any of these stew and a question comes to you. But by all means, please do reach out after today's event if you do have questions. So the first is we're going to witness another large-scale digital supply chain attack. All right, SolarWinds is probably the one that is in many people's minds already. SolarWinds is interesting, right? Because there was an API within that software stack. It can be tricky to kind of pull that apart and see like how could that be attacked as part of larger enterprise architectures and how organizations are kind of connected, right? That is what creates a digital supply chain. So not a simple problem, right? But this is kind of the realities of working with modern systems design, right? We're using componentry and applications from many different vendors and integrating things that creates a digital supply chain. We also saw some of this with Microsoft Exchange Server. That's actually still present where that's being attacked. And then more recently, you could actually say Log4j is kind of similar. I apologize. I think the font might be stretched out on your screen, but you'll have the materials, right? So APIs are kind of the foundations of digital supply chains. If you've heard me talk at any events, I talk about this relentlessly, right? But APIs are kind of what enable your business logic and data exchange, but also partner enablement, right? Most organizations don't operate in a vacuum. You can't satisfy all aspects of the business. You're going to be working with other partners and suppliers. That could be acquisition, right? Like something like SolarWinds software, but it could also be integrating your APIs with their APIs in order to provide functionality or exchange data sets, right? Very common. Most organizations do not do everything themselves. There's a lot of push in industry for zero trust architecture. It's not an entirely new concept. It is kind of the principle, least privilege kind of principles, and paired with behavior analysis, usually very identity centric, right? Because we need to know what any given user or machine is doing in that session, and then kind of adjust accordingly. Because we have to kind of assume there's zero trust, right? That environment could be compromised or somebody's doing something malicious. So that's kind of the concept of zero trust, but it's very hard to kind of accomplish that with technology. There's not just one product that you can buy. There's many. And a lot of focus in zero trust has actually been more on, I'd say, the network security side of things. So MicroSegmentation, zero trust network access technologies. You can even say secure access service edge. So things that are kind of network access control focused, but you're still missing kind of that identity and behavior analysis component. So there's moving pieces there, right? It's tricky to kind of get it all communicating together. And really this will actually tie into some of the other predictions, but machine assistance is really critical for enabling all of this. Because if you think about a digital supply chain, it is very vast. You have a lot of different environments and technology stacks within those environments, a lot of different signals or telemetry that you need to gather and then analyze, right? Nothing's going to look consistent across each organization because everybody kind of builds things uniquely, right? That's just how we work as humans. But we do need machines to kind of parse all of that information and kind of produce useful signals. The other part of this kind of prediction is based on dependencies, right? And there's a lot of focus in industry right now, I'd say, on software dependencies, but more so, and actually Log4j kind of reinforced this, but it's much more about libraries or open source componentry in an application package, or like Microsoft Exchange Server, right? What is the makeup of that software? What are all the binaries? I need to know those things, for license compliance, but I also want to know what are the known vulnerabilities. There's also quality measures that come as part of that, right? Like, is a code base actively maintained? How many code commits are actually occurring on this particular software package? Are there full-time active developers, right? Because those can be kind of indicators of is it quality code, right? Which could lead to bugs or vulnerabilities. So a lot of focus on dependencies is much more about that software makeup, right? And less so about APIs as an application dependency. And this is kind of where things missed the mark. We actually saw this also in the cybersecurity executive order. I believe it actually calls out software bill of materials explicitly in the full write-up. But SBOMs, they're just not incorporating API dependencies today. There's reasons for that. I'm not going to be able to dive too deep into the weeds today, but it's kind of the nature of the beast when it comes to software design and development, right? Vulnerabilities get cataloged as common vulnerabilities and exposures, or CVE IDs, and that's unique to that specific software package. When you're talking about APIs, it's a lot of custom application development. Unless you are a software vendor or publishing software, you're not necessarily going to report your weaknesses or vulnerabilities to track them as CVEs, right? So working with MITRE and NIST, right? Like cataloging these vulnerabilities, it just doesn't happen, right? So the nature of the beast with application design is there's a lot of custom coding that goes on, stitched together with these open source components and commercial packages. That's really the software makeup. So, SBOMs is definitely a step in the right direction, can help with things like Log4j, for instance. And also some of these other tech stacks that are named here, like Elastic or Kubernetes, right? These are all application packages that are evolving over time. Bugs and vulnerabilities are found. All organizations need to make sure they're kind of up to date. But there's also issues in how do you actually use that application in your internal infrastructure. It's another form of API. I sometimes refer to them as system APIs. Could be something that's kind of low level that's talking to that operating system, but it could also be a web API, right? Typically REST, but in the case of like Kubernetes, for instance, Kubernetes is declarative infrastructure via a REST API, right? So more like that web API pattern as opposed to an operating system call. But they're all APIs, right? So this is kind of where things get pretty nasty, right? Who's tracking all of these dependencies and the dependencies of those dependencies, right? It's very nested or transitive. And this is kind of why I think that we're going to experience kind of another large-scale digital supply chain attack. So that's kind of the end of the first one. I'll stop here in case any questions are coming in. Do we have any, Tom?
I do have a couple questions here for you. I really hope you're wrong on this prediction, though. We don't need another big supply chain attack.
You were telling me.
But I have a feeling you're probably right. I think you're probably right because of a lot of the stuff that I've been seeing and just doing a lot of these webcasts. Lisa has a great question, actually. Do technologies, from your experience, do technologies like zero trust or MicroSegmentation actually do anything to strengthen the supply chain?
Yeah, it's a good question, and I think that was kind of on this last slide here where I mentioned it. It's maybe not pulling up. There we go.
Hit it twice and then hit the green. And
yeah, so it can help, right? It's kind of network design. When you're talking about microsegmentation, it's probably more how our inner services or workloads communicating with each other. Those are kind of internal APIs to those microservices, and then what you expose might be a REST API or GraphQL API out to end user consumers. The microsegmentation can kind of help with land and expand type of attacks or pivoting within the internal network. So like the Exchange server instance is kind of a good example, right? An API was the initial attack vector. And then once you've compromised that server, now you can kind of pivot within that company's network and attack other systems. So those are very, useful technologies. They're difficult to actually implement and operationalize, which is another problem. But they're solving kind of, I'd say, network security or network access control issues. There's still kind of a broad spectrum of potential attacks that still occur in authenticated and authorized sessions, which actually is going to tie into another prediction. So I'd say it helps mitigate some of that risk of like limit the blast radius or that land and expand kind of attack pattern, but it doesn't really stop kind of all patterns of API attacks.
Okay. Appreciate it. Thanks, Lisa, for the question. Next, We've got one from Rick. Rick's liking the acronyms, I can tell. Do SBOM formats like SWID or SPDX help with tracking API dependencies? Sorry, I want to make sure I got all the acronyms right.
Yeah, so it's they're specifically the formats. I'd say the kind of the leading ones at this point. Predominantly used for tracking license information and vulnerabilities that could carry them. The issue tends to be, not all vendors have standardized on those schema formats, or they're machine ingestible typically. But the products aren't spitting out things in those formats. That's one problem. But the bigger problem is still, they're just not incorporating web APIs. Like, we're seeing most attacks, right? So if I launch an account takeover type of attack against a externally facing REST API, that's really not something that's going to be in scope for software build materials. So, as a practitioner, you're likely thinking of APIs as a dependency for all your systems, but it's not really in scope for these schema, right, or the way the tools address it. So it's kind of an unsolved problem. It's something we address within SALT, right? Continuous discovery of all your APIs and how they talk to other systems. And then, you can spit that out as like an XML format, but there is no industry standard at this point that's incorporating web APIs, unfortunately.
Okay. Appreciate it. Thanks for the question, Rick. Let's move on to prediction number 2.
Yeah, absolutely. I'm going to try to burn through these quickly too, so we have enough time for questions. So I did mention this, right? Access control mistakes. So organizations are going to continue to make critical access control mistakes, and actually, many of those incidents on that first slide were actually related to, I'd say, improper or misconfigured authentication and authorization, or deliberately designed poor authentication. Like in the case of Peloton, for instance, right? It's kind of a business decision to expose data in certain ways. So, why is this prediction likely going to become true? Access controls is really difficult to get right. And you could say, you could lump in network access controls like microsegmentation, but more specifically here, we're talking about, I'd say, identity focused, user identity and machine identity. But what is that user or machine doing within a session, as opposed to I need to make a connection to some service or workload? This also ties in kind of with those supply chains, right? And that's your systems likely are composed of many first-party API calls, right? The things you've built, or maybe that's a low-code platform, maybe it's entirely from scratch. But then also third-party API calls, right? What are those things you're calling out to? Usually some kind of SaaS-based delivery, but maybe it's even something basic like Google Maps, right? So how do you analyze that? How do you enforce consistent authentication and authorization? Are you passing things in that call that shouldn't be there, right? That's kind of a form of data exposure. Maybe you're inadvertently passing authentication cookies or session cookies, right, in that request to the third-party API call, right? That could potentially be harvested by an attacker. So these are kind of the problems that come up, right? And I won't have time to talk about it today, but like those inner and outer API calls, and then what do you do for a user authentication mechanism versus a machine authentication mechanism, right? And typically when you talk about machines, you don't have the luxury of doing an interactive challenge, right? The machine isn't going to know how to respond. So you talk about things like certificate-based authentication, or what is the machine state as a like IP address or configuration of that machine, right? Because there is no ability for that machine to respond interactively. It's not a human being, right? So authentication scenarios for machines are much different than user identities. Which really complicates this picture of authentication and authorization, right, and integration. GraphQL APIs also make this a lot more challenging because they combine or nest queries to back-end APIs, and that makes it that much harder, right? So as a mobile user, for instance, if I exercise a GraphQL call and that in turn calls 10 other APIs to satisfy the query, am I enforcing sufficient authorization on all those back-end API calls? This is kind of a big problem area. We're starting to see a lot of issues with GraphQL designs. And this is a kind of a favorite meme of mine. Maybe some people have seen it, but it's kind of the Cheeto as a door lock, right? We put the locks on, but are they easily bypassed or circumvented? This can happen quite frequently, right? It's kind of you focus on enforcing strong or robust access controls, but then you don't think about the abuse cases around them. This can happen quite frequently with identity and access management efforts, right? Because that's the world, right? We're very focused on authentication and mechanisms. Maybe we're using 2FA. For authorization, maybe we're using OAuth 2. So we're maybe focused on scope definitions. And not seeing the bigger picture, right? What happens if an attacker compromises some user session, right? It's kind of outside the scope of identity and access management, right? But it's still a problem for API security. Many of the API attacks we see actually occur in authenticated sessions, right? So an attacker has compromised that session in some way. Maybe they've hijacked the mobile application. Maybe they've just stolen authenticated state through some other attack, like a phishing attack. Maybe they've siphoned off data at rest from the mobile device, right? There's a lot of scenarios for that. And it can happen over trusted connections. Typically that's TLS these days, right? But your protected data in transit in that TLS connection can still be viewed or compromised. And I've actually talked about this, I think, on the prior prediction, but account takeover events are still a problem for most organizations and in all industries. But brute forcing and credential stuffing aren't typically addressed by identity and access management unless they start getting into that behavior analysis side of things, right? So if I identify an abusive caller, can I now trigger step-up authentication or dynamic access control, whatever you might call it, depending on your focus area. But that's typically what's required, right? So you have to be looking at what is that authenticated user doing that's potentially malicious, and coincidentally, that is kind of a zero trust principle, but not typically labeled as a zero trust technology. So yeah, identity and access management, very difficult to get right. I mentioned those incidents from 2021. If you dig in on them, many of them were basic authentication or authorization misses, right? So we're seeing it with very large companies and very consistently. I'd say at least once a month, we're seeing an event with one of the OWASP top 10 issues. All right, so I'm going to skip to prediction 3 just for the sake of time. We'll come back on access controls if there's any questions there, but I want to make sure that we're staying on track for time because I want to make sure everybody can get to wherever they need to for their next time slot. So for prediction number 3, another major brand will expose data and suffer reputational damage. This is actually kind of a nice segue when I was describing with 2021, kind of what's happened There actually is another blog where I talk about a lot of the biggest incidents of 2021. There's 7 of them. Peloton was one of them. Experian was another. But certainly take a look at that blog if you kind of want to see what happened, right? What were some of the technical specifics of what played out? And I talked about this earlier, right, on that prediction, but I see this pretty often in conversations, right? When you say data breach to a practitioner, oftentimes they'll think in concepts of a database server or some application server, and an attacker has in some way compromised that, right? Maybe they have root access and now they have full access to the data. So it's a very kind of traditional security definition that way. Unfortunately, that's not typically the way organizations expose data now. They do that through usually web APIs, right? REST APIs, or maybe it's SOAP for internal web service communication, or gRPC, right? There's a lot of API protocols, but APIs are the way that data is exchanged, right? Rarely are you doing like a bulk data transfer between database servers. So that concept of data breach is kind of, I'd say, legacy, for lack of a better term. And it's not just the fault of practitioners, right? It's kind of how a lot of industry regulation is written, right? Where data breach is kind of the main thing you should be worried about, right? Because you don't want to lose your data. The reality is you can lose your data in a lot more ways than just somebody breaching your networks or systems. One of the biggest that we see is scraping, right? This impacts a lot of the banking sector, but also e-commerce, right? And retail. That could be like a form of price scraping, but it's very rampant, right? Because the API is exposed data. If that's of value to some other party, they will call your API, consume the data, and then repurpose it in some other way. So the attack scenarios can change. And actually, some of those incidents I mentioned for 2021 were the result of scraping, right? It was a public API, so it was designed to be consumed by the larger public, exposed some data that was sensitive or private. But now when you have an attacker that can kind of query your entire data set or all users, now you have a privacy impacting event, right? So this is a significant problem, right? It's not just about a data breach. That's why it's kind of unfortunate that some companies will quickly dismiss an API incident as not a breach. And they're doing that largely for, kind of fend off legal repercussions. But I suspect this is going to change. But what we do know is that, there's going to be more major brands that suffer incidents. Will they dismiss them as not a breach? More than likely, right, until legislation and regulations are rewritten. But they're still leaking data in some way. Tying into that, right, with public APIs, yes, you are purposefully exposing some data. And actually, I think that I would kind of lump the LinkedIn data leaks with this, right? Microsoft investigated that. They found there was a very large data set that was appeared on the underground, right, on forums. Somebody compiled a data set that had a very large amount of LinkedIn data. I think it was like 700 million users. I don't remember the exact count, but a very significant data set. It looks bad, right? The optics on that are not good. You could argue that the attacker, yes, they did not breach Microsoft's networks, but they still scraped publicly available data and compiled this data set. So that's a privacy impacting event in itself. But then that data can also be used in other attacks, right? Then you start seeing upticks in phishing attacks or ransomware, right? Spear phishing, targeting, important individuals, those types of things. So really common, right? This can rabbit hole very quickly. Most APIs expose too much data, right? And that's why excessive data exposure ranks 3rd on the OWASP API security top 10. And this is kind of the design of, applications or systems. You have back-end API designers that aren't necessarily considering how should that data be consumed by outside employees or customers, right? That might be more in scope for the front-end designer. But then collectively, they're not considering all of the use or abuse scenarios for that API and its data. So you almost always find these cases of excessive data exposure with APIs. Leaky APIs are kind of a combination of weak access controls, right? So that ties back into what I was saying about identity and access management, but also exposing too much data. So in the case of Experian, it was deliberately designed to be kind of weaker, right? Because they wanted to facilitate data exchange with lending partners to provide credit scores, right? So how do you enforce access control there? It's very difficult to do. You have to do behavior analysis, right? Is somebody kind of calling my API excessively where they're harvesting these scores? That should not happen, right? That's not the legitimate business case. So leaky APIs are very prominent, right? Because of those integration scenarios, or considering, a machine consumer might need to hit the API. So I can't do very strong forms of access control on those clients. Stop there, Tom. Did any questions come in yet?
Yeah, I've got one. So you kind of just talked about it, but what is the excessive data exposure, and why do you think it's so prominent? I mean, why are we just pushing so much out there that anybody can grab?
Yeah, it's exactly what I described with like kind of that separation of back end and front end design. And it can get worse than that, right? Like those development functions may be outsourced, right? Maybe you've built the back-end API and now you've contracted with some consultancy to develop the mobile app for you, right? So now there's really no oversight into how that data is consumed. So there's a lot of ways that plays out, but yeah, typically design is kind of split up that way, right? Because the API can be reusable. And then you can have multiple types of front ends. Maybe it's an IoT device, maybe it's a mobile user, it could be somebody in a web channel. But APIs get reused in kind of different channels. So yeah, the API just kind of exposes the data, and then it's up to the front end often to kind of filter out what they should or should not see. Unfortunately, attackers know that, right? So they'll kind of expose the API communications and then look at what's actually being transmitted between the back end and front end.
I got it. Gotcha. Okay. Going back to your access control, Doug had a question. Do protocols like OpenID Connect or OAuth 2, do those help with access control mistakes?
Yeah, it's a good question. So I would say it can help with user authentication and authorization, respectively, right? OAuth is kind of your ability to delegate access to other systems and third-party APIs as a user. The problem with OAuth, I mean, there's a few, right? The protocol is changing, so new things get added. You can define coarse-grained and fine-grained scopes for limiting, what should somebody's authorization be to different services, but the picture gets very confusing when you think about like in the GraphQL scenario, right? If somebody's coming in and requesting some set of functionality, but that needs to call 10 other APIs in turn, how do I ensure that those scopes are tight enough, right? That's typically very hard to do. So organizations have a tough time kind of defining them that strictly. But even in those cases, right, it's there's issues with OAuth, right, with open redirects. Are you checking to see where somebody might get redirected after they've authorized that connection? And the protocol, like I said, is changing. There's other also mechanisms with OAuth, like PKCE, but that can inhibit mobility, right? So now you can impact user experience. So there's trade-offs, right? And it's like how far do you go with forcing all of these access controls on a user before it becomes damaging to user experience or your integrations?
Right. Fine line, right? Okay. Excellent. Let's move on to prediction 4. Sounds good.
Yep. All right, this is an interesting one. Maybe some people will cringe. It depends if you are in the GRC role in your organization, but we live in a world of compliance, right? That's nature of the beast with security, but you could argue many things in life, right? Compliance is a reality, right? There are rules and restrictions on how we should be doing things, and that's certainly true in IT and security. So governance and risk and compliance teams are usually a significant function in most organizations as part of information security programs. But we're already starting to see this at some of our SALT customers where those teams were starting to ask more questions about API security, right? So you might not have considered that, right? It might have been more your AppSec team or development or network, right? Like I said, it varies. What's your role? What are you accountable for with respect to APIs in your organization? But kind of all functions of IT are asking about APIs. So like I was saying, right, compliance is there. Most companies have their own internal sets of compliance policies that they want all employees to abide by. They also incorporate other regulations or standards like GDPR or PCI DSS if you are handling credit card payments or processing that data. So there's a lot of things you need to be accountable for as an organization or an individual that works with data, or those systems that work with that data. So you have to answer to auditors, right? That's the reality. Maybe it's once a year if you're lucky, right? Nobody loves the auditor knocking on their cubicle door like, hey, do you have this thing? Or, these days maybe it's a Zoom call or an email. But audits are a reality, right? We have to deal with them, and we have to have satisfactory answers. We see this already, where OWASP API Security Top 10 is being used pretty readily in procurement process, right? So when they look at a vendor product, does it meet the OWASP API Security Top 10? Not all vendor products can. And it's kind of, it gets into the weeds of how their particular solution might have been architected. But procurement teams are asking these questions, right? Because they might not know all the specifics of API security or have all that subject matter expertise, but the OWASP Top 10 can become some measure that they can use for product selection. We also see it used as a measure of security program efficacy. So are all the things you're doing, do they help mitigate all of the issues in the OWASP API Security Top 10? So in the case of excessive data exposure, what are the fields that you're exposing? And does a gateway allow you to mask a particularly sensitive field? That might be a way they approach it. Or for access control, right? Because the first two items on the top 10 are authentication and authorization related. How do your API gateways enforce access control policy and integrate with your identity and access management systems to support that? Right, so it spiders out, right? OWASP API Security Top 10 can kind of be the entry point to those things. And many data security standards already apply, right? If you are familiar with PCI, the data security standard, or DSS, it's evolved, right? I think we're on 3.2 currently, but the language gets tightened up over time and clarified. But today it doesn't really spell out APIs very specifically. It just kind of talks about this large category of public-facing web applications. But we know that most organizations, the way they're architecting their applications are by designing and building APIs, right, or integrating those APIs. So they are the web application, right, and then you have your front end that might talk to that API. So it's in scope, right? It might depend on what is the quality of the auditor, right, to assess that information and actually ask for API specifics. But like I said, we're actually seeing this already with Zolt customers, so expect it to kind of trend upward from here. The other thing that makes this interesting, and actually you kind of mentioned it right when we started, Tom, and it's, when you talk about API flaws, it could be a code issue, right? Sometimes things are dismissed too quickly as being the result of poor coding. That's not often the case. I mean, you might even say rarely is it the case. It could just as well be an issue with your access identity and access management policies, or maybe a piece of infrastructure or a security control is misconfigured, right? There's a lot of different moving pieces. It's not always just a code level issue when it comes to an API flaw. And this is another reason governance, risk, and compliance teams might get involved, right? Because they're working with app dev, but they're also working with other functions in the organization to make sure they're satisfying security requirements and meeting policy. CI/CD build pipelines do provide auditability. I actually saw this fairly commonly as a Gartner analyst, where I would talk to a compliance somebody in a compliance role in their organization, and they wanted to get up to speed on DevOps and DevSecops, want to understand, well, how does CI/CD help me? How can I do what I need to do as a compliance person? And it's kind of, leading them to the fact that, when you do things in CI/CD, they're codified, which means they're readily auditable. So it can actually help them achieve their goals pretty quickly. Unfortunately, DevOps maturity is still relatively low in industry, right? We're not all where we'd like to be. Most organizations, you're not Netflix, you're not Facebook. It's a very long journey to get there. Okay, so we got about 20 minutes. I have, I think, three more predictions we're going to cover. So I'm going to skip questions for the compliance crowd at this point. If we have them, we'll get to them in the next section. All right, so number 5, security operations teams will seek more API visibility and context. What do I mean by this, right? Maybe you are a SOC analyst or you're in that security operations role. These days, it could be labeled as cybersecurity, right? A significant component of cybersecurity programs for many organizations is actually more on the operational side of things, and specifically security operations, right? What are all the things going on in my network? What are all the users doing? What's the state of the infrastructure? What's my attack surface, right? You could argue that cybersecurity, as opposed to I'm going to get involved in all the things going on in development, which quite honestly kind of gets shoveled off to DevOps or DevSecops or application security. Maybe it's labeled as shift left. So there is very much this kind of the splintering of security focus. So cybersecurity can actually be much more infrastructure focused as opposed to application layer and API layer. That's a problem, right? Like I just mentioned, API flaws can result as a result of a code level issue, but also some problem in infrastructure or other security controls that are outside of the code. For SecOps practitioners, MITRE attack framework is typically the common language, not something like OWASP API security top 10. So now we have kind of this language barrier in a sense. And CVE IDs, I mentioned these briefly when we were talking about SBOMs, but that's not the complete picture, right? That might help you if it's a vulnerable piece of infrastructure, or maybe Log4j, for instance. You could update that library. Hopefully, maybe if it's a third-party application, you have to go to the vendor to get the new version of it. But patching kind of takes on a different meaning, right? It's not that simple where you can just launch an executable and the thing is ready to go, particularly if it's custom code. So SOC analysts, right? Because this is a prediction, and we know that APIs are being readily attacked. They're going to be looking for this kind of translation into API context, right? It's not their world. They're likely not plugged in with development. Maybe they partner with development teams to get that, whatever the logs, the intelligence for that in the event, in the case of an event. But they need this translation, right? And that's typically going to be facilitated by machine intelligence, for lack of a better term. For most SOCs or SecOps teams, that's typically SIEM, right? Security information and event management platforms like Splunk or Elastic, right? There's quite a few, but that's kind of where they live and breathe, right? That's the aggregation point for everything going on in the enterprise. Unfortunately, it can be very infrastructure focused, right? So it might be IP addresses and servers as opposed to URLs and API endpoints, right? So when you look at it, you can very quickly see it's not necessarily the right context you need when you think about an API-related attack. Like, would a SOC even know if somebody is scraping an API? Probably not, right? Unless somebody is very kind of deliberate in how they're doing that, right? They're not throttling their connections. They might see that as kind of a traffic spike that looks anomalous. So this very quickly becomes a problem. And organizations typically have, digital forensics and incident response processes that they need to enact when they see something anomalous or experience an attack. They're going to need API context, right? So there's going to be much more of this demand from either systems or from teams to other teams to provide that kind of API expertise. All right. Tom, I'll pause for, let's just take one question because I've got two more I want to burn through.
Yeah, definitely. When it comes to the SecOps, this question is not really about necessarily the visibility, but how do you get more collaboration between the teams? Because oftentimes we hear that, the developers versus the operations folks, they're kind of button heads. So how do you kind of make some progress there?
Yeah, it's some of it's cultural, right? With not giving the fluffy answer, but the reality is everybody's pressed for time, right? So you have the things you need to do. If you're a developer, you're trying to create code to satisfy business functionality. If you're a SOC analyst, you're just trying to figure out what happened for a given event. Part of it is the language, right? Developers are talking in terms of how they coded something. They might not even be versed in security-related incidents or MITRE or OWASP, right? Maybe it's not their world, and vice versa, right? The SOC analyst doesn't care about the code. They care about security taxonomies and classifying events. That's typically where the machine intelligence comes in, right? You need systems that can do that translation for you automatically, alleviate some of that from the practitioner, right? Because if you were to do that manually, well, the SOC analyst has to have some app dev experience, and then vice versa, right? You need an app dev that has some security knowledge. I've seen some of that attempted with like security champion work, but it's very difficult to scale that. Typically you have large development teams or things are outsourced, so you do need that kind of machine assistance to do the translation, but then also feed the relevant data to the right teams as part of a work stream or a workflow. Typically that's API integrations, right? So developers are working in their Git-centric processes, so they have Git version control, they have their IDE. You need to kind of get the information there, or if you have to ask for them, certainly present it there. They're working within defect tracking, not your vulnerability management platform, so you need integrations there. And so it's typically about integrating between the systems that all of these non-security teams are working within, as well as security teams. So everybody can get access readily to the information they need to do their job.
Excellent. Appreciate it. Thank you.
Yep. Good question. All right. So number 6, organizations start distinguishing API security as unique from DevSecops. I was kind of alluding to this one earlier when I talked about that that fracturing of security, right? How some things have become cybersecurity, and DevSecops has kind of become the landing zone for all things kind of app dev, or maybe modernized infrastructure. And that's kind of the point really here. One of. The other is when you say DevSecOps, typically organizations think shift left, right? So they want to push as much of their security testing and implementation of protections earlier into the lifecycle of that application code or API. When you think about applications and APIs, they don't just run by themselves, right? They have to run on infrastructure, right? Or application infrastructure, as I sometimes refer to it. That could be something like, it could be bare metal in your data center. It could be virtualized. It could be containerized. Maybe it's cloud hosted, right? There's a very large spectrum of infrastructure that can run your code. It could even be serverless, right? So it's abstracted from you. But most of the focus in DevSecOps is kind of these things, right? It's either on the app code or delivering that app code into a container and then very quickly instantiating it and then maybe tearing it down and respinning it up, right? You can very quickly rabbit hole into things like immutable infrastructure and infrastructure automation. But those are typically the focuses within DevSecOps, right? So it's very much on code testing or container image testing. There are tools that are very prominent in this space. I've taken too many calls, honestly, so like hundreds of hours of talking about application security testing tools, which vendor is better. The vendor discussion kind of, it's the same at the end of the day, right? Because it's kind of how these tools are designed and the stage that you run them in the SDLC, they can only detect so many issues, right? So even the best vendor product, maybe 40% efficacy, right? So some larger organizations might run multiple to try to hedge their bets and catch more issues, but it's kind of the nature of the beast. They can't catch all issues, and some issues don't manifest themselves to your running that application in some environment, right? And then you can kind of observe behaviors. But it's just not how the tools are built. Typically, they looked for exploitable conditions like injection flaws, maybe something like Log4j, right? Because you could inject code there, but it depends. Like, at what point did you analyze that code, or did you analyze the complete application sequence on running infrastructure? But in most cases, actually almost all, I would say, business logic flaws, they're not covered by application security tools. Some container security vendors will operate a container in a sandbox and kind of observe its behaviors. How is one container talking to another? But it's very focused, I'd say, on network access behaviors. Like, is this container talking kind of anonymously to another container that isn't normally the baseline, as opposed to, well, here's the API context on top of that, and that, what is this parameter within that API call that they're abusing? So it's kind of still more rooted in that world of infrastructure. The other piece of this prediction is that application security and API teams are going to continue to evolve to meet the demands of API security, because they are very demanding, right? It's cross-discipline, right? Hopefully that's apparent at this point in the presentation, right? Rarely is it a code level only issue. It could be things in infrastructure. Some of those things become clear as you advance into like cloud native design and you are using infrastructure as code techniques, right? And maybe you own all of that soup to nuts as a DevOps practitioner, but that's not the case for most organizations, right? It can still be kind of splintered, particularly for a large enterprise. And you may still have old infrastructure, right? Bare metal and virtualized instances that you don't own all of the pieces. API schema analyzers are also kind of something that come up in this domain, but schemas are something that not every organization are creating because it is a documentation process. So you may not even have schema to analyze. But just like SAST and DAST, when you talk about application security testing, they're limited in what they can find if you're only analyzing the API schema. So tricky problem, right? And that's why I kind of say API security is going to be this primary focus, as opposed to let's just grow our DevSecops program and hope it solves everything. All right, and number 7, I think we're relatively on time. We'll probably have time for one more question after I get through the last prediction. And that's that automation is going to gain favor for securing the shifting attack surface. And really the attack surface is APIs when you dig in even just a little bit. Automation kind of permeates most IT efforts, right? If you've been in IT, you've been seeing this, I'd say, for the better part of a decade, particularly if your organization has undergone some digital transformation initiative. But automation is the name of the game. You can't scale, right? You're never going to have enough headcount. You can't satisfy all workflows, so you need to find ways to integrate systems and workflows, like I was describing earlier, right, with the defect tracking, and how would a SOC analyst talk to a developer without kind of butting heads? Automation can alleviate some of that, right? If it just gets triggered as part of an event detection, well, now it's the system asking for some piece of information, as opposed to an employee, which might infer bias or aggravate the other person, right? So automation actually helps kind of silently on those fronts as well. But you also can't argue with it, right? It's kind of the machine. It's based on what it's seeing. That's actually defined in code and being built, right? So within DevOps, when you start digging in, a lot of it is about automation and repeatable process. Security has to fit that model, right? Otherwise, you're going to be kind of a roadblock or barrier. This is kind of basics of security, right? It doesn't change. We need to automate in order to kind of keep pace with business. I've talked about this kind of throughout. I think it was actually in the first prediction, but machine assistance is kind of the only way that you're going to be able to keep on top of all of the API telemetry that's in place, right? When you think about all of your first-party and third-party communications, it's not just those things you formally mediate in your API gateway instances. It's not just your most critical business applications. Your attack surfaces much more than that, right? There's the APIs you know of, and then there's the APIs that you don't, right? Or shadow APIs. So machines can be gathering this telemetry, producing useful signals, and then presenting that to you, so you actually can do your regular job, but then also proactively address new potential threats. Just to kind of reiterate some of those points, and actually this I'd say ties even to cybersecurity, but mean time to detection and mean time to remediate are usually like primary metrics that a lot of organizations gauge themselves against, right? When they're thinking about efficacy of what they do, how long did it take somebody to find an issue? And then if it took 6 months to fix the problem, what's going on, right? Do we have a staff problem? Is there a technology problem? Was it outsourced code that somebody dragged their feet on? But they're indicators of some type of issue, as well as efficacy within your security program. Automation can help accelerate them, really. Manual testing doesn't scale, right? I touched on that briefly when we talked about application security testing. That's an hour-long discussion in itself. When you talk about testing applications and APIs, it can be time-intensive, 2 weeks or more, right? If you want to do a very deep assessment, rarely is there time to do that level of analysis. And then when you talk about doing automated testing in build pipelines as part of CI/CD, that focus within shift left, you very quickly run into a scenario where you're failing builds too much. And I talked to many organizations that were in that boat because you're always going to find problems, right? And it might be low-hanging fruit. Maybe you pulled in a library that has some low severity vulnerabilities in it, but now you're failing that build because that library is included in the full code base, right? And it's aggravating the developer, and now you can't get code out the door to meet the business goals. So that happens quite frequently, right? What do you do with the results? And that's actually what most automation discussions were about with security testing. And the last one, right? If you are a CISO, you have my sympathies, right? These are not easy days. We talked about a lot of API incidents that are occurring. There's security threats on all fronts. Burnout is real, right, for everybody in industry, but certainly CISOs, right? They take a lot of heat or stay up at night thinking about all these potential attacks, right? But as a CISO, you increasingly have to present things in a business context, right? It's not just about these are the things we need as far as headcount or security budget to fix the problem, right? Typically, the CISO would get challenged and ask, well, how does that help the business, right? So you have to present things in business term. That can be things like alleviating workflow constraints, not so much, it might save us from these types of attacks because that's an unknown, right? You can't predict that, but you could argue that it'll help improve mean time to detection or mean time to remediate. So think about that, right? Regardless of the role you are in the organization, think about the tooling you're doing, the tooling you're implementing, or the processes that you're working within. Do they help facilitate this automation and actually help you meet the business objectives that are in front of you, right? Because that's going to roll up to security leadership and your CISO. And with that said, we got about a minute, so I'll very quickly run through these. They're all clickable links. There's a lot of content on all things API security. I don't want to spill the beans, but there's some very juicy things coming in the next couple weeks as well that I'll be publishing, so stay tuned on that front. But if you have any questions about this material or anything else that you wanted to talk to me about, please do reach out through email or LinkedIn. With that, Tom, I'll pass it back to you in case any other questions came in.
Appreciate it. No more new stuff. Some of it was kind of duplicated that you'd kind of already covered, so I don't want to get into those. But real quick, though, could you kind of give us just a real quick, maybe like a use case or a workflow where automation, maybe you just kind of popped in. I'm going to extend our time just a few minutes because I want to hear this myself. But where you used automation and it actually kind of saved somebody's,
Yeah.
bacon.
Yeah, actually, I can give you some customer examples. I don't know if I can name the company, so I'll steer clear of that. But I
Okay.
talked about the risk of account takeovers, right? The threat of that. And there's different ways an attacker might perpetuate that. It could be brute forcing, it could be credential stuffing. But this customer had implemented Salt to kind of do that analysis of their APIs. They saw that there was an anomalous activity against its APIs that are indicators of brute forcing, credential stuffing, and very quickly mitigated by integrating with their perimeter gateways and load balancers, right? So, if somebody is calling excessively, like in that case of credential stuffing, they might have been throttling requests. I can't even remember the exact number, but they were doing just enough to kind of stay under that threshold of the strict limits that were already in place on their gateways. But we still detected that because it was a behavior anomaly, right? So then now they can make the adjustments to the rate limits on their perimeter gateways as a result of that detection. And that's all done through APIs, right? And that, like I was saying, that's kind of what underpins automation. It's very much about how can you integrate APIs between systems, right? And that systems need to be fully API enabled to do that. But yeah, that's kind of the sequence to get there. But yeah, that's a good example I could think of an actual workflow.
Appreciate it. I liked it. I followed along and it made sense. So I appreciate that.
Right,
So.
awesome. Good stuff.
Thank you so much. Well, like Michael said, we're kind of at the end of our time, I should say. Let's kind of move to our closing. We do have a lot more remote sessions on the way. So if you're looking for CPEs, or you're just you need some more topics, or you're just trying to work on some different projects there at the office, or you're securing the organization in general, right? We've got next Tuesday on January 25th, securing the software supply chain by following the audit trail. That's coming up. Resolution intelligence for situational awareness. That's going to be on Thursday, the 27th. Data privacy insights. We've got a special one. This one's on a Friday. We don't normally do these on Fridays, but hopefully you can join us on Friday, January 28th. This is a special one for data privacy insights. Should be a great little panel that we put together there. And then moving into February, we've got nuclear ransomware 3.0. That sounds scary. We thought it was bad, and then it got worse. This one must be a know before. This sounds like a know before title if I've ever heard one. That one's February 10th. So join us there. There's a link in the resource tab. You should be able to join any of those that you want. Of course, we send out emails to invite you as well. Certainly, as we're wrapping things up here, I want to say thank you again to Mr. Michael Isbitski for his great job with the different 7 predictions. Great stuff. Thank you so much, Michael. Let's see
thank
here. You. And of course, thank you to the folks over at Salt for making it possible, for hiring Michael, for that matter. He wouldn't be here today if they hadn't hired him. So thank you for that.
Yep.
This concludes today's remote session. And everybody have a great rest of your day. Be well, be safe, be healthy, and all that kind of fun stuff. We'll see you Tuesday, it sounds like. Be well. Take care.
Excellent. Thanks. Take care, everybody.